Hello class. We're going to now take our factoring to another level and use them to solve some of our polynomial equations. So we're going to be looking at the zero product theorem and the square root property in solving our equations. Right now we're going to be looking a lot at quadratic equations. Now a quadratic equation in X is an equation that can be written in a particular form, in the form ax squared plus bx plus c is equal to 0. And that equal to 0 is going to be how we're going to be able to apply a zero product property and be able to solve. Now our a, b, and c have to be real numbers, so no imaginary numbers in these, and a can't equal 0. If a were 0, it's no longer a quadratic equation. But let's take a look at how we're going to do that. We're going to take that ax squared plus bx plus c, and we're going to factor this trinomial. And we will apply the zero product theorem. Which states right down here, if the product of two algebraic expressions is 0, then at least one of the factors is equal to 0. So let's take a look at some examples. So we've got the equation 3x squared minus 9x equals 0. And our strategy here is going to look at or factor this. This one is not a trinomial, but we're going to factor this equation. And one of the strategies we have for factoring is the greatest common factor. And we're always going to look for that first anyways. And 3x squared and negative 9x have a common factor of 3x. So if I factor that out, 3x squared divided by 3x is x, and negative 9x divided by 3x is negative 3. So that's the factored form, and it's still set equal to 0. Now the zero product theorem states that either 3x is equal to 0 or the x minus 3 is equal to 0. We're going to solve for both and find the possible solutions. So on 3x equals 0, I'm going to divide by 3 so that these cancel out, and I have just x is equal to 0. On this other one, I've got x minus 3 is equal to 0, so I'm going to add 3 to each side to get x all by itself. That cancels out. We get x is equal to 3. So my solution, we're going to state x is equal to the set of 0 and 3. So we have another one here. But before we can even start trying to solve for this, we want to make sure that the equation is set for 0. This one is not. It's set equal to 1. So I'm going to subtract 1 from each side, and I get 2x squared plus x minus 1 is equal to 0. Now it's equal to 0, and we're going to factor this trinomial. This trinomial is going to be factored into two binomials that equal to 0. There's no greatest common factor, so I'm going to go straight to factoring into the binomials. 2x squared has the factors of 2x and x. Negative 1 has the factors of negative 1 and 1, so one of these will be plus and one of these will be minus. So I want to make sure that when I take 2x times 1, that's going to be positive 2x, and the x times negative or times 1 is going to be the negative. Oops. There's a negative sign. So it's 2x minus 1 times x plus 1. Now we're going to set each one of those factors equal to 0 and x plus 1 equals 0. And we're going to solve for this. So this first factor, we're going to add 1 to each side of the equation. And we'll get 2x is equal to 1. And we want 1 by itself, so we'll divide by 2. And we get x equals 1/2. Then we're going to solve this one for x, and we're going to subtract 1 from each side. And we get x is equal to -1. So these are our two answers, 1/2 or -1. There's another really nifty way of solving our quadratics, and that's by applying the square root property. So if we have an algebraic expression and we call it a, and b is going to be a non-zero real number, we can have, let me see, here we go, we can have a squared equals b. That will produce, and if we're solving for a, that's going to produce two solutions for a. Because we take the square root of each side. Oops, that's supposed to be equals. Get back to my color. So that equals plus or minus the square root of b. So we'll have a is equal to plus or minus the square root of b. So that's the square root property. Let's apply it to something with numbers. So we have an equation here, and we could do it the way that we've done it before, where we factor out a common factor. But let's apply the square root property to that. So instead of setting it equal to 0 and factoring, we're going to get x by itself and then take the square root. So I'm going to add 21 to each side. So I'll have 3x squared equals 21. We want x squared by itself, so we're going to divide by 3 here. We'll get x squared is equal to 7. When we take the square root of each side, the square root property says that this side has to have a plus or minus on it. So I'm going to say that x is equal to plus or minus the square root of 7. We're going to keep it as a radical because that is a more exact answer. Let's try one that's similar, but it has a very different way that it gets the answer. So once again, I'm going to subtract 45, the constant, from each side of the equation. And I get 5x squared is equal to -45. So I'll divide by 5. Oops. And I get x squared is equal to -9. So when I take the square root of each side, we're going to get x is equal to, and remember that's got to be a plus or minus well, the square root of 9 is 3. Oops. But it's a negative, which makes it not real. But we remember, hopefully from Algebra 2, that the square root, let me put this up here, the square root of -1 is equal to I, that imaginary unit. So we would say x is equal to plus or minus 3i. And yes, we will at times have imaginary units as an answer to our quadratics. One last example here. On this one, if we wanted to factor this like we did earlier and apply the zero product, we'd have to, multiply this all out using FOIL. But we're going to apply the square root property because we can just take the square root of each side of this equation. So the square root of x plus 5 squared is x plus 5. Now we're going to set that as that it is equal to the positive or negative square root of 11, leaving it as a radical. Now we want x by itself, so I'm going to subtract 5 from each of these. So we get x all by itself, and it's going to equal -5 plus or minus the square root of 11. That really is two answers. You can leave it like this, or sometimes you'll see it written like this. X is equal to -5 plus the square, oops, I just did that by force of habit. Take that off. All right, so -5 minus the square root of 11, or x is equal to -5 plus the square root of 11. You'll see them put together and you'll see them pulled apart. Just depends on the author or who is writing this down.